Assalamualaikum warahmatullahi wabarakatuh. My name is Risya Aziera Binti Sukarno from RY40G3. In this lab session, we were doing lab 2 operational amplifier. In operational amplifier, we have two applications, which is comparator and summing amplifier. For the comparator is an electronic decision-making circuit that make use of an operational amplifier that very high gain in open loop state. There is no feedback resistor. For the OM comparator, basically have two comparator, which is zero level detector and also non-zero level detector. First, the procedure is comparator zero level detector. So here is a circuit zero level detector. So what can I do is construct a circuit at multisim based on circuit that given in lab sheet. Then after construct the circuit based on the lab sheet, play. Show that the sine waveform apply to be non-inverting, so that we can see it positive. When the sine wave is positive, the output at maximum positive level. When the sine wave are across to 0, so when the sine wave is at a 0, the amplifier is driven to opposite way, and the output go its maximum negative level. So when it's 0, so output for the negative output goes to the maximum negative. For next circuit is called as a non-level detector. This circuit non-level detector are using voltage divider to set the reference voltage known as a Vref. To calculate the Vref equal to R2 divided by R1 plus R2 times with positive V. In this case, positive V is the positive OM at DC supply. Then after we connect the circuit, in this circuit, R1 is 4.7 kilo ohm and R2 is 1 kilo ohm. So we get a waveform Vin is a 5 volt. When Vin a 5 volt, the Vref I calculate the Vref, we get 2.63 volts. So Vin is more than Vref. When more than Vref, it maximum positive V out. Then if the Vin is less than Vref, so it remains the maximum negative V out. So in this case, it not remain, but it goes to its maximum positive V out. After that, I change R1 into 2k kilo ohm. R2 is remain as 1 kilo ohm. So the waveform we get when I calculate the value, Vin is equal to Vref. So the value are acceptable in graph because it's not lower than the VREF is not lower than Vin. That's why we get Vout is remain as a positive maximum. After that, change R1 into 1 kilo ohm. After I change the R1 1 kilo ohm, the waveform are same with the previous one because Vin is lower than a VREF, so it remains the positive at maximum voltage negative. V out is remain negative maximum. Next, go to summing amplifier. Summing amplifier is a application of inverting OM that combine the voltage present on two or more input. For the circuit, R2, R1 and RF is a same value 10 kilo ohm. So when we run, we get Vout is 1.9985 volt. When I calculate the value, I get negative 2 volt. I using Vout is equal to negative RF over R1 times V1 plus RF divided R2 times V2. So I get negative 2 volt. For the experiment, I get negative 1.89 volt. Then go to the second. For the second circuit, I change R2 to 2 kilo ohm. So I get negative 5.997 volt. When I calculate the value, I get negative 6 volt. So here is a summing zero amplifier. It does not have a RF, but it connect like a non-zero level amplifier. So when we run, it get a value like a non-zero amplifier. The question asks, what do you understand about summing amplifier? Summing amplifier is application of inverting operational amplifier that combine the voltage present with two or more into a signal output voltage. When the voltage output that is equivalent to an amplified sum. What happens to the output if the frequency of the source is increased to f equal to 3 kHz? What happens is when OM frequency is increased, the gain of amplifier is decreased. After completing this lesson, students be able to demonstrate and investigate a comparator circuit, which is a comparator circuit has a two, which is zero level detector and also non-zero level detector, and also student able to demonstrate and investigate a summing amplifier circuit by using a multisim software and use to find Vout by using formula that was given. That's all for me. Thank you.